Okay, so we are currently on the chemical reactions and stoichiometry unit. And the last thing that we did when we met right before spring break was we spent the whole day on stoichiometry, which is mathematical or quantitative relationships between reactants and products in a chemical reaction. And we know that in a balanced chemical equations, the coefficients not only stand for numbers of particles, they also stand for numbers of moles. And so therefore, any two substances in the same balanced equation are related to one another through the mole. And to solve stoichiometry problems, most of them are solved in 3 steps where we use conversion factors. So we go from grams of what we start with to grams of what we end up with, and we go through the moles. So we go from grams to moles, moles to moles, and moles back to grams. And you had some homework assignments to do over the break, which I have posted answers to. So make sure you look at the answers to those assignments and correct yours and email me with any questions that you might have. So if you didn't get something right, you understand why you got it wrong so that you don't make the same mistake on a quiz or on a test. And if you don't remember stoichiometry, if you did the homework right away and it's been a long time, you want to review some of those in-class problems that we did, because we did about 4 or 5 in-class problems. We did a lot using stoichiometry. So we have 2 more things to finish, and then we will be all done with this unit, and then we'll move into our next unit, which is states of matter. The 2 things we have to finish are limiting reactants and percent yield. So the first one is limiting reactant. A limiting reactant is just a reactant that limits the amount of a product that will form. So it's when you start with a certain amount of each reactant, which one limits the amount of product that will form. And the next video that I'd like you to watch after you finish watching this one is going to go through a limiting reactant problem and a percent yield problem that I'm going to show you how to actually work out the problems, because it's harder for me to, it's not easy for me to do that using the PowerPoint, easier using a whiteboard app that I found. So let's go through a practical example of what we mean by a limiting reactant. So let's say you work at a bike shop and your job is to assemble bikes. So we know that the reaction for assembling a bike is that it takes 1 frame and 2 wheels to make a finished bicycle. So let's say your bike shop gets a supply order and you get a shipment of 25 frames and 75 wheels. We want to know how many bicycles can you make from the equipment that you got in that shipment. So in other words, I want to know what supply limits the amount of bikes that can be made. Is it the number of frames that you got, or is it the number of wheels that you got? So let's start with the number of frames. Oops. So each frame takes 2 wheels. That's what it says in our balanced equation up here. So if we get 25 frames, we need 50 wheels. So by using 50 of the wheels, we can assemble 25 bikes, but we've used all of the frames, so we wouldn't have any more frames and we can't assemble any more bikes. So the number of frames would be the limiting component in our shipment, and we'll have wheels left over. So this is a practical example of a limiting reactant problem. So it's the number of frames that limits the number of bikes that can be built. The last thing then in this unit is percent yield. And percent yield is just a way of determining how good a reaction is. How much product does it make compared to how much it should have made? So the equation for percent yield is actual yield divided by theoretical yield times 100. So let's go through what actual yield means and what theoretical yield means. So actual yield is just what it says. It's the amount that's actually produced in the experiment. So for instance, in the lab that we just did, the one where we made copper, it would be the amount of copper that was actually produced. So after you dried the copper in the oven, or I dried it for you and gave it back to you and you massed it, that's your actual yield. Now the theoretical yield is a calculated amount, and it's the amount that should be produced. So based on the amount of copper chloride that you started with in that experiment, how much copper should be produced? And you can calculate that using stoichiometry. So this is the end of this video. It just went through the last couple of slides in the PowerPoint and I narrated them. And now you should watch the video that goes through an example of doing a percent yield and a limiting reactant problem.